In this exercise, you will retrieve and display in 3D the benzene and lithology models that you created in an earlier exercise. Adjust the display of the lithology model to view the distribution of the clay material in relation to the benzene hotspot. Create a 2D map representing the thickness of that clay layer. Create a 2D map representing the benzene plume and overlay these with transparency applied. Draw a clipping polygon on this map to create a polygon table. Clip your benzene and lithology models with this polygon and display them in 3D. And create a cutaway view into the lithology model to view the contaminant.
We'll start by creating an isosurface display of the benzene01.rwmod model. Click on the Project Manager tab from within the main RockWorks program window. Click on the small arrow to the left to expand the Solid Models heading. Double-click on the model named benzene01.rwmod, which you created in an earlier lesson. You'll now see the Solid Model to 3D diagram window. Click on the Main Options tab at the top of this window. Don't worry about the data columns. The program will ignore these since no source data points are being included in this drawing. Click on the 3D Solid Diagram item and choose the isosurface option. Disable or uncheck the other diagram options. Click the Continue button located at the base of the menu. RockWorks will now display the model within a new 3D window. Double-click on the solid item within the data tree to access more display options. Set the ISO level value to 45 and press the Apply button. Notice two things. Number one, the isosurface has significantly shrunk to only show concentrations greater than 45. Number two, the volume displayed within the isosurface options dialog has decreased from roughly 8 million to 1/4 million cubic units. Click the Close button at the base of the isosurface options dialog. Select the Save option from within the File pull-down menu in the RockPlot 3D window. When prompted, enter benzene01 isosurface.rw3d.
Now, let's append your previously saved lithology block diagram to the contaminant isosurface. Click on the Append option within the RockPlot 3D menu ribbon. Select Lithology Model.r3d file and click Open. If you are prompted to overwrite the lithology or stratigraphy types tables, click No. RockWorks will now append your lithology diagram to the plume diagram, obscuring the lithology plume in the process. So let's filter the lithology diagram to show a specific material type. Double-click on the Lith Solid option within the data tree. Uncheck all of the lithotypes except for clay. Click the Close button. You'll now see the benzene plume and the underlying clay layers. Take a moment to adjust the view, zooming in and out, rotating the image, etc. Note that the clay layer is pretty much continuous without other interbedded materials. This will be important when performing the next step within this exercise. Click the Save As button and save this composite diagram as benzene01 isosurface plus lithology.rw3d. Close the Solid Model to 3D diagram program.
RockWorks contains some useful tools for creating surface or isopach models from lithology models. In this exercise, we'll determine the thickness of the clay materials shown within the previous exercise. Select the grid-based option from the 2D isopach pop-up menu. click on the Input-Output tab within the Main Options page. For the input, browse for the lithology1.rwmod file that was displayed within the previous 3D scene. For the output, type in the name clay-isopach.rwgrd. Click on the Lithologic Unit tab and select the clay lithotype. Turn on the 2D grid map option, enable the colored intervals, enable the labeled axes, enable the map overlays, turn on the borehole locations, enable the symbols and borehole IDs, enable the peripherals option, turn on the colors option, change the color legend title to thickness, turn on the border option, and press the Continue button. RockWorks will read the lithology solid model and determine the uppermost and lowermost elevations for the clay voxels in each vertical column of nodes in the input model. The thickness of this interval will be stored for the corresponding node in the output grid model, the RWGRD file. A null value is assigned to any grid nodes that do not have any clay within the original lithology block model. Please make special note that this isopach process includes all materials between the uppermost and lowermost clay voxels in the model, regardless of the materials that lie between. In other words, this tool should be used with caution when your lithology model contains many interspersed lenses. Select the File Save option and save this map as clay-isopach.rw2d. Close the Lithology 2D isopach window.
In the previous chapter, you created a statistics map for some time-based data being toluene. In this step, you'll do the same thing for benzene iData measurements. Choose iData Statistics Map. Set the iData track to benzene soil. Set the map type to Z equals highest value. For the output grid name, enter benzene soil highs.rwgrd. Click on the Gridding Method tab and set the algorithm to Kriging Automatic. Enable the 2D grid map option. Enable the colored intervals. Turn on the Omit Lows option. Set the low cutoff to 45. Turn on the Contour Lines option. Set the intervals to Manual. Set the minor interval to 5 and the major interval to 20. Turn on the labeled axes. Activate the map overlays. Enable the borehole locations. Turn on the symbols and borehole IDs. Activate the peripherals option. Enable the colors legend. Turn on the title and set it to benzene. Activate the border option and click on the Continue button. Now let's do some image preparation so that we can append this map to the lithology isopach map. Notice the Layers pane located along the right side of the RockPlot 2D window. You can widen and lengthen this pane as necessary. Uncheck all of the items within the Layers pane except for the default and contour bands. Right-click on the layer titled Contour Map.Contour Bands and select the Set Layer Opacity option. When a small dialog appears, set the opacity to 50%. Select the File Save option and save this map as benzene soil highs.rw2d.
At the end of the previous step, we left off with a contour map of the benzene soil highs. Before combining this map with the clay isopach map, we need to right-click on the Contour Map.Contour Bands layer and select the Edit option. Rename this layer to Benzene.Contour Bands so that it won't be combined with the isopach color bands in the next step. Click on the Save button. Select the File Append option. Pick the clay isopach.rw2d file. Don't pick the rwgrd file, pick the rw2d file. RockWorks will append the clay contours on top of the benzene contours, thereby obscuring the benzene contours, and display the map in a new RockPlot 2D window. You can move the benzene layer to the front of the display by right-clicking on the benzene.contourbands layer and select the Bring to Front option. The benzene plume is now plotted on top of the Lithology isopach. Notice that you can rename layers, change their opacities, adjust their plotting order, or delete them entirely. Click the Save button and name this combined map Benzene Soil Highs plus Lithology isopach.rw2d.
Temporarily turn off the distracting layers within the Layers pane. Select the Draw Line Types Polygon option. Draw a polygon around the outside of the plume by clicking on the polygon vertices in a clockwise or counterclockwise fashion. Double-click when you are finished, and the program will automatically close the polygon. Click on the Edit arrow. Click on the polygon that you just created. You'll know if you correctly clicked on the polygon if all of the vertices are highlighted. Right-click on the polygon and select the Save to Polygon table from the pop-up menu that appears. Enter Benzene Clipping Polygon when prompted for the name of the new polygon table. Close this window. You do not need to save the diagram because we got what we needed, which is a polygon table.
To view the polygon table that you created in the previous step, double-click on the Project Manager, Project Tables, Map/Model Tables, Polygon Table, Benzene Clipping Polygon item. This sample table editor allows us to examine, edit, export, and plot the polygon. But for now, we just wanted to show you what it looks like, so go ahead and close it. We will now use the polygon table to construct a 3D scene of just the lithologies within the area where the benzene concentrations are highest, i.e. the polygon area. So please select the ModOps Solid Filters Polygon Clipping program. Enter lithology1.rwmod for the input model. Enter lithology1clipped.rwmod for the output model. Click on the Options tab and select the benzene clipping polygon that we created in the previous step as the polygon table to be used for the filtering. Configure the program to replace nodes outside polygon with null values. Enable the 3D solid diagram option and set the block diagram type to voxels. Click on the Color Scheme tab and set the scheme to Lithology. Enable the perimeter cage. Enable legends and turn on the Lithology legend. You will now see a diagram that only shows the lithologies within the clipping polygon. Add the benzene plume by selecting the Append option and selecting the Benzene 01 isosurface.rw3d file. The benzene plume won't be obvious because most of it is hidden within the clipped lithology model. To address this, double-click on the polygon clipped solid item within the data tree and set its opacity to 25%. You will now see that the contaminant is confined to the sands and gravels, whereas the clay may be acting as an aquitard. Let's clean up the data tree a bit before we continue.
Right-click on the polygon clipped solid, select the Edit Title option, and change the title to Lithology. Do the same for the solid, but change it to benzene. Delete the redundant perimeter cage. When you're finished, click on the Y Rotate option to view the diagram from other angles.
Another way to view the relationship between the contaminant and the lithology is to add a cutaway view. Start by unchecking the checkbox next to the clipped lithology diagram. Click on the Append option and load the unclipped lithology model.rw3d file. Right-click on the lith solid item within the data tree and select the Add Cutout option. The solid model cutout dialog will now appear. Select the southeast corner for the cutout. Set the cutout dimensions as shown within this example and click on the Apply button. This cutaway confirms that the contaminant lies within the sand, gravel, and silts and above the clay, as we saw within the transparent view. This diagram can be enhanced by appending another copy of the lithology model.rw3d file and double-click on the new lith solid within the data tree to view the lithology model options menu. Click the None button to hide all of the lithologic units. Enable just the clay unit. This helps to depict the geometry of the clay bathtub that is constraining the contaminant migration.